Hi there. In this video, I will talk about box and whisker diagram, and judging by the name, the diagram has a box and two lines. It's called whiskers because they look like whiskers. Okay. Now, box and whisker, or often called box plot, has some representative values of the data, which are the median, minimum point, maximum point, lower quartile, and upper quartile. Okay, so therefore it is useful to give us a visual representation of the data, and that include the interquartile range, or the 50% of the data. All of these, okay, are called 5-number summary. So when you see the 5-number summary, that means all of these. Okay, let's try to make a box and whisker. Given this set of data, what you need to do firstly is to rearrange the data from the lowest to the highest value. And then you try to find the middle value, or the median, by dividing the data equally. Yeah, and that is equal to 6. And looking at the lower half of the data, you divide it equally to find the lower quartile, which is 4, and you do the same thing to the upper half of the data to find the upper quartile. Yeah, and let's display the box and whisker. I have also included some notes about quartiles and interquartile range as well. You can pause the video later on and have a look in case you need it. Okay. And next we will talk about the interquartile range and the connection with the outliers. Okay. Statistics assume that your values are clustered around some central values. If you look at this example 3, our data values are clustered around this central value. Okay, same thing with example 4. Our data are also clustered. Same thing in example 4. Our data is also clustered around these central values. Okay, these central values can also be used to tell when some of the other values are too far from the central value, and these are called outliers. Here is the formula for the upper boundaries, which is at that end of the box and whisker, which is equal to upper quartile plus 1.5 times the interquartile range. Any data bigger than this is an outlier. And for the lower boundaries, which is that end of the box and whisker, is equal to the lower quartile subtracted by 1.5 times the interquartile range. Any data smaller than this is an outlier. Okay, let's take a look at this example here. Given the set of data, you are asked to generate the 5-number summary and later on check whether 18 is an outlier. Okay, let's generate the 5-number summaries. We have the lowest value and highest value, so we can find the range, okay, which is highest minus lowest value. We can find the median, and then lower quartile, upper quartile, and of course interquartile range. And we can produce the box and whisker, or box plot, like so. So next we want to check whether 18 is an outlier. Now since 18 is at this part of the box and whiskers, so we will only be using the lower boundary. Okay, and the lower boundary is equal to 52, right? That 52 minus 1.5 times 35, yeah, and that gives us negative 0.5. Therefore, 18 is not an outlier. In this last section of the video, I will briefly talk about box and whisker and normal distribution as a part of the requirement of the new IBDP math syllabus. Okay, so basically, when the box and whisker or box plot is symmetrical, as you can see, this line is of equal length to this line, and this part of the box is of equal size to this part of the box. So when the box plot is symmetrical, then you can say your data is normally distributed. Okay, that's when your box and whisker is symmetrical. When the median of the box plot is closer to the top of the box and this whisker at the upper end is shorter, then the distribution of your data is left skewed or negatively skewed. But when the median is closer to the bottom of the box and if whisker here at the lower end is shorter, then the distribution of your data is called right skewed or positively skewed. Okay. Thank you very much for watching the videos. I hope it helps. Take care.